Good morning. We are Belt Architecture and are pleased to introduce our capstone presentation on Tangerine. Tangerine is a six-floor mixed-use building featuring a hybrid structure incorporating mass timber and concrete elements in Calgary's University District. At Belt, our team has four members: Ethan Toledo, the Science and Systems Lead; Beck Erklo, the Technologies Lead; Min Lee, the Documentation and Regulations Lead; and Jasmine Barcina, the Research and Design Lead. Tangerine offers a blend of commercial and office spaces to boost job opportunities as well as provide amenities of multiple interests. The residential aspect of the building is designed to accommodate individuals from various demographics, with a particular focus on catering to students. Our vision is about fostering a dynamic community ambience through meticulously planned communal areas such as outdoor gathering spaces, dedicated work environments, and fitness facilities tailored to the needs of both students and professionals.
Our site is located within Calgary's vibrant University District, nestled at the intersection of Perrotin Avenue and McLaurin Street. Facing McLaurin Street to the west, our site enjoys prime visibility and accessibility. The primary access to the site is via Physical Plant Road, with an additional entrance conveniently accessible from McLaurin Street. Surrounded by a mix of land use designations, including special purpose and direct control, our site itself falls under the direct control designation. This diverse zoning enhances the dynamic character of the area. Adding to our site's accessibility, a bus stop is conveniently located at the front, facilitating easy transit access for residents and visitors alike. Notably, our project takes a proactive approach to parking provision, offering only a limited number of parking lots. This intentional choice encourages the use of alternative transportation modes such as public transit and cycling. Moreover, the site's strategic location ensures that most amenities are within walking distance, further promoting a sustainable and pedestrian-friendly environment.
Initially, our team envisioned an H-shaped building with two tall sections on each side, floor in the middle, acting as a bridge for the courtyard. However, this design posed significant challenges. Not only did it limit sunlight access to the courtyard area, but the square shape of the taller sections also hindered creation of an effective residential unit layout, resulting in substantial wasted space in the middle of the floor area. After conducting case studies of apartment buildings in the neighborhood, we recognized that a U-shaped design offers greater efficiency in floor plan layout. This realization led us to implement a U-shape which not only addressed the inefficiencies of the previous layout, but also significantly improves sunlight access to the courtyard area throughout the day and across all seasons.
Here we have our building site plan with the principal entrance located at the north, and visibility triangles located at each corner required. Originally, our site consisted of the hatch square to our northeast as well, but we eventually shrunk our site down as it drastically increased our workload.
Here we have our site's parking space, the borders of which hold soft landscaping to serve as a buffer between the sidewalk and the parking area in order to comply with the bylaw. This parking lot holds 44 stalls, 3 barrier-free stalls and 2 loading stalls, one for residents moving and the other for garbage disposal.
The main floor layout of our Tangerine building features two entrances, the primary entrance on the north side and another on the south side. Both entrances lead to lobbies providing access to office and residential floors, utility areas, and 2 building offices dedicated to either residential layouts or for future tenants. The main floor hosts a total of 10 retail spaces, including one designated for a restaurant, offering flexibility for both consumers and renters. Additionally, we have included a wind tunnel area that incorporates benches and creates more window and entrance opportunities for retail stores, maximizing their exposure to the public.
On our second floor, we have designated leasable office units covering a total area of 2,413 square meters. Alongside these units, the second floor features a public lobby, 2 water closets, a janitor room, and electrical mechanical room on both the north and the south side of the building. Given the size of our building, 3 staircases are incorporated to meet the travel distance requirements outlined in the National Building Code.
On the third floor, we have residential units, and they're divided into 4 categories: studio units, 2-bedroom units, 3-bedroom units, and 4-bedroom units. Our studio units are primarily tailored to cater to student residents, reflecting our commitment to affordability. Consequently, we've made strategic adjustments to maximize cost effectiveness, such as omitting dedicated storage and laundry facilities. Instead, we've opted to provide a communal laundry area to promote energy conservation. Additionally, we've thoughtfully incorporated a communal study area, serving as both a workspace and a shared hub for residents. For those requiring additional storage, a separate storage room has been allocated. Adhering to NBC requirements, we looked at NBC Table 9.10.3.1 to select wall types that meet the necessary STC and FRR criteria. Furthermore, the third floor features a serene courtyard space, complete with seating benches, fostering opportunities for socialization and interaction with residents while enjoying the view.
For our floors beyond the third, they are largely the same, with the only notable difference being that the laundry room is alternated with a gym on the 4th and 6th floor, and some suites are a little bit larger now that courtyard access isn't needed. As for our roof plan here, the main point of interest would be our central mech room. Originally we had opted for a north and south mechanical room on each floor, but we decided that would be excessive and isn't typical for buildings of our type. So with a bit of work, we repurposed our old mechanical rooms into vent shafts. Now from the roof, our RTUs would then go down these shafts and travel to each residential suite, where they would be met with a heating panel and travel within these bulkheads, providing exhaust and ventilation to various locations within each suite.
Aesthetically, our building is based on its already existing environment. With our goal to blend in, the materials we chose for this building are black and orange metal composite panels from Alucobond and black and red brick.
Here we present a detailed illustration showcasing our exterior cladding system and its integration with the backup wall. This visual depiction shows the connection between the brick veneer on the main floor and the metal cladding on the second floor. The brick veneer is securely supported by brick ties, which pass through the insulation layer before attaching to the gypsum sheathing, which in turn is fastened to the steel studs. This strong anchoring system ensures the stability and longevity of the brick facade. Additionally, at the junction where the brick and metal composite cladding converge, a metal flashing is installed. This critical component serves to effectively divert water away from the wall assembly, safeguarding against potential moisture infiltration and ensuring the durability of the structure.
As for my detail, I chose to highlight the courtyard's floor system, since it was not something I had prior experience with and was curious about how a typical courtyard floor system looked. An item of particular interest was the floor system itself and how it's actually a protected membrane roof system, and how everything was layered, beginning with brick pavers on the surface, which are held up by adjustable pedestals, followed by XPS insulation, drain board, vapor barrier, and most importantly, roofing membrane, which sits right upon the concrete slab, away from potential damage caused by the friction of the pedestals, as well as the extremities of temperature. Late into our project's development, as we were detailing, we had also noticed that there was space between the concrete wall and exterior wall insulation, potentially creating a dew point within the framing. At this point in time, it was too risky changing the position or thickness of any walls due to how that could impact any number of views, so we decided to solve this issue within our details instead. One such solution was to add insulation within the framing of the wall, then veering the air vapor moisture membrane from the exterior gypsum layer towards the concrete wall, then adding an air moisture membrane along the exterior gypsum layer so that any possible vapor buildup from the dew point can leave the wall's framing before it becomes an issue.
We combined concrete floors and columns up to the second floor, transitioning to mass timber from the third floor up, inspired by the Brock Commons project. For concrete, we used 2,800mm by 2,800mm by 700mm pad footings, 500mm by 500mm columns spaced at 5 meters interval. We also incorporated a 1.6 meter thick raft footing and 250mm deep foundation walls. Mass timber features 265mm by 215mm glue lam columns spaced roughly 4 meters and 2.85 meters apart, with 3-ply cross-laminated timber floors. We chose a post and panel system for affordability despite its narrow column spacing to suit our focus on students and small family unit. For our column connection system, we opt for the pillar system after considering various options including the glue bond system and spider connection system. The pillar system stood as the most advantageous choice due to its ability to support the edges of CLT floors in a manner akin to a table structure. This unique support mechanism eliminates the need for a moment-resisting connection between each floor panel, thereby reducing overall project cost.
The different stages of this project throughout the semester really helped my group and I understand the experiences an AT would normally deal with, from the challenges posed by a detail to the satisfying success of a well-thought-out plan.
Our capstone project Tangerine would cost around $55,500,000 if it were to be built on this location. Thank you all for being here today to watch our presentation.